All right, thank you very much, and let's dive into it. So I'm Nedbal, I'm from Shipunk, I'm principal engineer, whatever that means, and let's talk about that code. So every project has a dev code, even yours, even yours, even yours. Everybody of you have some dev code in their projects. And the problem is that it slows down everything. It slows down development, it slows down CI, it slows down practically everything. But the problem is how to detect the dev code. How do you know that the code is actually never used? So there are two approaches how to be sure or at least suspect some parts of the code that are actually not used. So you can run the code and somehow detect that it's not being used. That's the runtime analysis. And you can use multiple principles to check what's not being executed and what is being executed during runtime. And one of the things that you are probably aware of is something called code coverage, because there are things like xdebug or pconf that can tell you which lines of code were actually executed. You can run it in production, and you will get like the best result you can ever get in terms of code coverage in production, meaning you will know exactly which lines you can delete. But the problem is there is significant performance overhead. So basically nobody does that because slowing down your production for 30% or something like that, nobody dares to do it. So you can do something that's called tombstones. That's a pretty old concept, and it's nothing more than just logging which methods are being used and which are not. You can do it like manually in your methods and use any kind of logging system and then check what was never called and then delete those kind of things. So that's also an option. You can, in PHP, you can think about autoloader, that is logging which classes were ever autoloaded and which are not. There will be almost no performance degradation for that, so that would be very good, but the scope of that of the dev code you can detect is only class level, which is, I would say, suboptimal. And there is the, like, I would say, modern part, and that's the static analysis, like detecting the code without running the code. And this points to, obviously, there are multiple parts of that. You can detect that members, that code branches, like specific else ifs, and even the dependencies in your vendor. And this part typically goes to some static analysis tools like, for example, PHP.live, which we will talk later about. So this is some overview of existing tools that you can use. And the sad thing in PHP is that there is not much good stuff. There is, from Sebastian, PHP dev code detector, but it's not maintained for about 10 years, and it was actually never working well. Then there are those tools that Shipunk built, and one of them we will dive into in this presentation. And for the runtime analysis, there are, I would say, more concepts and ideas than actual production libraries that could be used in production. So basically, there are the UNU, which is a really nice concept, really nice article on the internet, but nobody uses it. There's like 10 downloads for packages. Then there is the CrackJoe tombs, which is like super performant automatic tombstones via Zend extension that automatically injects the logging in all your methods during production, and it's really well designed to have almost no performance degradation, but it's broken since PHP 8.1. You can try it. I just assumed from the issues on GitHub. And then the only thing that's actually being used, maintained, and it's like working, it's the tombstone library that allows you to manually add the tombstone logging calls, which is, I would say, really suboptimal because you don't want to have in like every method this specific call. So let's dive into the static analysis part and the part that is allowed thanks to PHP-Stan, and that's our library that's called dev code detector, and actually PHP-Stan extension. So even without our extension, when you run PHP-Stan with some defaults, it will also detect some dev code, but it's very, very limited since it's by default only checks the scope of one file, and which means that you can detect only things that are deducible just from that scope of a single file. So private members, like private methods, private properties, and those kind of things are reported. And also there are some always false conditions, so which means you create a problem with always false condition, you will know that it will never be executed and it's actually a dead code. But that's not enough. The real thing happens in public methods because everything is public method and everything goes through public methods. So this diagram shows how PHP stun collectors work. Ondřej spoke about it today a little bit. So you have plenty of files, plenty of classes in your code base, and there are things called collectors which are designed just to pick data from those files. It's up to you. We are collecting definition of all the methods, and then we are collecting all the calls of those definitions. And if you think about it, if you just subtract those, if you subtract calls from the definitions, you obviously get the dead part, which seems like super simple. And that's actually how this library worked in version 0.1 or something like that. So it gives some results. You can wipe code it in one day, but there are some major downsides to it. And of course, all that only works when you analyze a whole code base, because otherwise with partial analysis, when you are not checking everything in your code base, you will never get dead code analysis at all. It just doesn't work. So it's even disabled when you are doing partial analysis in PHP stun. But the main problem there is transitivity issue. Because when you just divide definitions and calls, you only scratch the surface layer of the dead code, which means when there is a chain, like the facade method is calling service method, which is calling repository method, only the first one appears to be dead. But actually, the whole subgraph is dead. So you would need to run PHP stun over and over and over again, all the layers that are dead, and it would be like, I would say, pretty bad developer experience. You don't want to do it. You want to do it in a single run and see all the dead things in your code base. And luckily, we implement it in further versions, and it actually works like that, and it actually shows you within the single PHP stun error, and it shows you all the subtree calls that are dead because of the first one. So it knows all the things that are called in your code base, and it groups them this way so that you know that once you delete the first one, all the others will appear dead, so you can delete all of them. How? The trick is to build something that's typically called call graph, which is just a graph of all the calls. And since you know all the calls, you can start with something called entry points. So for start, imagine that everything is dead, and you need to pick parts of the graph that you start marking white, start marking used. And those are the things that don't have any originating method. Typically, it's the global scope or some framework calls like Symfony controllers or something like that. And then you just go through the graph and mark everything white. And the benefit implementing it this way is that it even starts working for dead cycles, which means when there is a cycle in your code that is being called like transitively to itself, then those kind of things are suddenly appearing as dead code, even though all of that have usages, and even that all of that has some calls. So this is like major improvement, and also it helps you with that you need to run it just once, and you will see everything. So this could be like end of the presentation, because this is the main concept that will work in like isolated code bases that are not present in the real world. The real world has the problems of frameworks, vendor, and all kind of magical calls that are present in the real world. So we need to deal even with that. So let's start with some major improvement that is there for, I don't know how many versions, but the idea there is that every overridden method that originates in vendor is called by some vendor code, which means we automatically support any non-magical library. Because when there is some interface in vendor and we implement that interface, it's supposed to be used in vendor. So we just call those parts as used, and we transitively go starting from those. So that's the first part that suddenly in the real world helps with a lot of libraries, and it helps you with many false positives that would be there. Okay, you might think, okay, but my framework is much more magical than that. There are methods that are being called that definitely don't have any like real method in the vendor. There is no interface or anything. And for those kind of things, there is built-in support for many libraries that are being used in the wild, mostly Symfony, Doctrine, and those kind of things. And there is support for many, many magical calls. So if you are using one of those, it works out of the box, and it's implemented for how the framework actually works inside. Okay, so what if there is some special magical calls inside your calls, inside something that's not being supported by our library by default? So there is an extension point, which is called member usage provider, and you can just call it just based on the reflection, which is the most easy part. You can call it that it's being used based on something. So if you can decide based on the reflection that you know that it's being somehow called some magical way, you can just treat it that way, and you only need this simple usage provider. Okay, so that would kind of works, but what if your code is tested, right? Everybody has tests, and which means those tests are creating usages. So none of your code is that, right? Because everything is tested. So if every method is tested, it has some call. That's a problem, right? So we need to somehow exclude those cases. And there is a built-in support for that. You just say, let's enable this excluder of test, and suddenly it treats all the calls that's being called in tests as like excluded, as not part of the evaluation. But the important thing here is that it still maintains that code detection within tests. So things that are defined in tests and not called in tests are still reported. This is only for defined classes that are defined in source, not the test. So only things that are actually tested, which are defined in source and used in tests, those are being exported. So, or your, for example, that data providers in PHP unit or something like that, that's still being reported. All right, there are more things how to do magical things in PHP. For example, you can call something that is unknown to PHP stand. We are still in PHP stand, right? So there are things that PHP stand are not aware of, and those are mixed types. So if you have mixed thing that's being used as a method name, then it just marks all the methods of user as used. Because if we don't know which is that, we don't want to report any false positive, we just mark all methods of user and all possible descendants and everything that could be there as used. And similarly, we can do it with unknown caller. And obviously, if you would ever call unknown over unknown, then you don't need any dead code detection at all, because it would mark everything as white, and we are just ignoring it because it kind of breaks everything, but it emits some kind of warning in verbose mode. So reflection, that's another thing, how to do magical calls that are kind of invisible, but it might be needed. So support for reflection is there too. So the first one marks constructor, the second one marks the name constant, and so this is fine too. And for those who do open source, you are probably thinking, okay, but I'm doing open source, which is a library, not a typical application of some company that does some things, but I'm building code for others. So there are some surface layer APIs that are being used by others. And this is like by definition that, because it's prepared for usage. So for that, we have support of API annotation, which is kind of starting to be used in PHP Stan and Rector and those kind of modern libraries. So we added support for it, and it's been proven to work very well because even PHP Stan itself is using our library, and it was working. It was already there. The API annotations were already there, and it was working flawlessly. So sometimes it gets like really complicated. Traits and inheritance chains and all kind of things might get really complicated in the call graph. And understanding all that is not trivial, even though for me, and I implemented this library. So it started as a debug part for me, but then it's part of the library. So you can even see how the library is seeing some usage of specific methods. So if you are some suspicious that something is behaving incorrectly, you can just see what's going on. So you just place the method in some debug part of your configuration, and you will see the first thing that marked the specific method as alive, and then you will see all the usages that were found in your code base, and obviously the excluded ones will be somehow marked that those are not counted. And since we are in PHP stan, for everything else, everything that works in PHP stan still works here. So you can use everything that you can use in PHP stan for ignoring errors, and all that will work here. The config, the inlines, everything. But there is one great thing that's like above that, and you can somehow abuse those usage providers as a smart ignore tool, because you can write PHP code how to ignore certain things. So if it's getting tricky in some parts of your code base and you are seeing some kind of pattern, you can say, okay, let's not deal with that now. I'm going to create a fake usage provider, and I will say, okay, let's not deal with like dead things in interfaces, for example. And let's go to some more, I would say, practical part, the things you would probably ask anyway. And that's the elimination itself. So until now, it was all about finding the code, and then you would go through it and delete it. But the idea is, well, I have a tool that can detect it. Why not delete it? So we implemented, it's a little bit hacky way. There's no way how to do it differently in PHP stan. But if you use error formatter that's called remove that code, it just deletes all the methods. And with the transitivity, with everything, it maintains your ignores, it maintains everything. So everything you have seen in the output of PHP stan, with a single line in your CLI, you can delete everything. Obviously, if there are excluded usages, they are kept, and those are seen in the output, you need to deal with them. So typically, the tests, you need to go there and delete them by themselves, but it still saves really, really significant amount of time when dealing with like huge refactorings that there are many leftovers. And there is still one part that was missing until now, and that's the entry points, right? Because the entry points are the thing that are kind of defining what's dead and what is not. But what if the entry point, something we call entry point, for example, control error, what if it's actually dead? What if it's actually never used in production? So if you somehow combine production usage data from some of your observability, I don't know, we use Datadog, for example, and if you have those kind of data and you can compare it with those entry points, then you can delete like thousands of lines just by creating single excluder that says, I know from my production data that this control and this method is actually not used. And doing so, you will exclude the entry point, and all the subtree behind it will be deleted as well. So this is the example of our production data. We have some metrics which are saying some request hits of some Symfony controller. There's some resource name, and we can see that since August or since September, it was never used. So I'm pretty sure that I can put this one in my excluder and then delete everything that was beneath it. And while iterating over that, you can then easily see those kind of merge requests that were done pretty much automatically. Like I would say 80% of this merge request was done with the single delete my dead code error formatter. Okay, so how do you start with that? Because if you have a big code base, then the first run, even with all those implemented smart things, you will probably see something that feels like false positive, but it's typically something that's been tricky, or you need to like help it a little bit with some usage providers or something. So I would start with like making the errors like empty for start, like ignoring things that you want to deal with later. And those are some of the examples that we started with. So for start, we we ignored all the getters because there is typically nothing beneath the getters. We ignored entities for start. We ignored abstract methods for start. We ignored constructors for start because those are really tricky if you have dependency injection containers and those kind of things. So start with that by ignoring some parts that are not that much important and focus on the main business logic that's being dead. So you can start with ignoring things and then like removing those parts, those ignored parts to get the full dead code detection without any keep it for later things. So is it stable? We use it since 2022, which is 3 years now. And our code base is almost 2 million lines, which means basically anything that can be built in PHP in terms of all the inheritance chains and craziness that can happen, it happened already in our code base, and it's been beta tested because it works on our code base without a single false positive. It's used by PHP.stan itself, so even PHP.stan is using our tool in the CI, and that's a library that's like really complex, and also have many lines of code, so it's working flawlessly even there. And recently, even infection library started using it, and that one is pretty big too. I'm not sure if this is super updated, but the usage is rising, which feels that it's like really stable because there are only very few issues being reported, and most of those are feature requests or things that we should implement and not any kind of bugs. So for now, it mainly focuses on methods. That's the main part, and that's the most important part because almost all your code lies within methods. It can also detect dead constants and dead enum cases, opt-in only for now. And the future scope, there are many ideas I plan to implement, but let's see. First of all, that properties, that classes, that parameters, useless visibility, you name it. There are some kind of things, so many things that could be there, for example, next year. And that's it. Like it, start it, use it.
Thank you, Honza. Like the previous presentation, my question was answered during your presentation, but I can ask it one more time. What is the highest number of removed lines of code after you're running your cleanup?
Well,
3,000?
No, it's much more. I think we deleted about 50,000 lines of code, something like that. It was multiple merge requests. I didn't do the calculation.
50,
it was tens of thousands of lines of code, yes.
Yeah, it could have a pretty much impact.
Yes.
But there are no any more questions. So that's all. Thank you very much.
Thank you.